Let's go through some of the most asked questions during interviews regarding Spring Boot. I have put together a list of 25 questions which either I encountered during my own interviews or which I asked during interviews to candidates throughout the various companies I worked at and I interviewed as senior engineers. Of course, this list could be very long. I might consider doing a part 2 if you guys like it, so let me know in the comment box below, and I hope you find it useful. So let's start. Spring Boot is a framework built on top of the Spring framework, and it simplifies the development of production-ready applications. It removes much of the boilerplate configuration required in traditional Spring applications by providing sensible defaults and auto-configuration. The main advantages include eliminating XML configuration through Java-based configuration and annotations. It also provides embedded servers like Tomcat or Jetty, so you don't need to deploy WAR files. It also offers starter dependencies that bundle commonly used libraries together. For example, the Spring Boot Starter Web MVC dependency contains multiple dependencies within it. So by simply adding this, we will be getting a bunch of other dependencies. Spring Boot also includes production-ready features like health checks and metrics out of the box, and it provides a command line interface for rapid prototyping and development. Explain the concept of auto-configuration in Spring Boot. Auto-configuration is Spring Boot's intelligent feature that automatically configures your application based on the dependencies you got in the pom.xml file. So when you add a specific library, Spring Boot detects it and automatically sets up the necessary beans and configurations. For example, let's say we had a H2 database dependencies in our pom.xml. Spring Boot would automatically configure a data source bean that will look like this: an embedded H2 database and connection pooling without us writing any configuration code. The only thing we would need to do is go to our application.properties and add some of the configurations such as the username, password. I'll show in one of my videos how to use H2 database together with JPA to create a quick prototype, so you can check that out for more details. So all of this happens through conditional annotations like conditional on class, conditional on missing bean. That checks for the presence of certain classes or beans before applying configuration. What are Spring Boot starters? Spring Boot starters, such as these ones you see on screen, are dependency descriptors that bundle together a collection of related dependencies for a specific functionality. Instead of manually adding multiple dependencies, you add a single starter that pulls everything you need. This was a game changer when Spring Boot came out, as you didn't have to manually add a bunch of dependencies, and this is what allows to have very quick turnaround time when building anything using Spring Boot. For example, with this Spring Boot Starter Web MVC dependencies, we get Spring MVC, Tomcat as the embedded server, Jackson for JSON processing, and validation libraries. The Spring Boot Starter JPA brings in Hibernate, Spring Data JPA, and transaction management. This approach greatly reduces dependency management complexity and ensures compatible versions of libraries work together. So once you do this, you are sure that all the versions that are included, for example, the JPA or the Hibernate version in this starter pack, are going to be compatible with one another, so we don't have to worry about that. What is the purpose of Spring Boot Application Annotation? So the Spring Boot Application Annotation is a convenience annotation that combines three important annotations into one. It includes the configuration annotation, which marks the class as a source of bean definitions. It contains the enable auto configuration, which tells Spring Boot to start adding beans based on class path settings. And finally, the component scan annotation, which tells Spring to scan the current package and its sub-packages for components. How does Spring Boot's embedded server work? Spring Boot includes embedded servlet containers like Tomcat, Jetty, or Undertow directly in your application jar. When you run your Spring Boot application, it starts the embedded server programmatically without requiring external server installation or WAR file deployment. The embedded server is configured through the Spring Boot starter web dependency, which we saw earlier, which is this one, and we can customize server settings in our application.properties file under the resources folder. This approach simplifies deployment because your application becomes a self-contained executable jar that includes both our code and the server. Explain the difference between component, service, repository, and the controller annotations. These are all stereotype annotations that mark classes as Spring managed components, but they serve different semantic purposes. Component is the generic stereotype for any Spring managed component and is the base annotation for the others. The service annotation marks a class as a service layer component that contains business logic. The repository tag designates a class as a data access object, which is also called a DAO, and provides automatic exception translation for database operations. We then got the controller annotation, which marks a class as a Spring MVC controller that handles web requests. Using these specific annotations makes your code more readable and allows Spring to apply specialized processing. What is dependency injection and how does Spring Boot implement it? Dependency injection is a design pattern where objects receive their dependencies from an external source rather than creating them internally. This promotes loose coupling and makes code more testable and maintainable. In this example, you can see that the order service is using constructor injection to implement this payment service and email service class. And as you can see, these are Spring managed beans, so we are not doing anything like payment service equals to new payment service and etc., because this is all being managed by Spring dependency injection. Spring Boot implements dependency injection through something called the IOC container. IOC stands for inversion of control. You can use constructor injection, which is the recommended approach, setter injection, or field injection. The container creates and manages the life cycle of beans and injects them wherever we need them. So the IOC is going to manage these beans, such as the payment service or the email service and the order service itself. And whenever we need this in a new class, we can simply use, for example, the constructor injection, and we don't have to worry about instantiating these classes. The IOC is going to do that for us. How do you configure properties in Spring Boot? Spring Boot supports multiple ways to configure properties, with the most common being application.properties or the application.yaml files. These files are automatically detected in the class path and loaded during application startup. You can see here we can define the application name, the port where our Tomcat server is going to be running. We can also define some other properties that we can use throughout our project. We can then access these properties using the value tag. This annotation is for individual properties, or if we have multiple properties that are related to a Java object, we can use the configuration properties. Spring Boot also supports profile-specific configuration files like application dev properties and environment variables. For example, let's say we wanted some applications just for the prod environment. We could have something like application-prod.properties, and these would just apply to production. So let's say we wanted to run this in port 8090 in production. This is what would be picked up. What is Spring Boot Actuator? Spring Boot Actuator provides production-ready features for monitoring and managing your application. It exposes various endpoints that give you insights into application health, metrics, environment properties, and many more options. Common endpoints include the Actuator health. For health status, we've got the Actuator metrics. For application metrics, we've got the Actuator info for application information, and also Actuator N for environment properties. We can secure these endpoints and customize which ones are exposed, and we can do that using the application.properties. So you can see some properties that we can use to manage these Actuator endpoints. Explain the concept of profiles in Spring Boot. Profiles allow you to define different configurations for different environments like development, testing, and production. You can create profile-specific property files and beans that are only active when the profile is enabled. So in this case, we could have two separate beans, one for production and one for when the dev profile is active. You can see in our resources folder, we've got an application-prod property and one application.properties. If we put them side to side, we could have two different kind of databases. So when we're running in production, we want to connect to an actual Postgres DB. And when we're running on our dev environment, we can simply just connect to a H2 database. You can also see the different kind of logging. We want more logging when running on local and less when running on production. Spring Boot looks for file names named application hyphen the name of the profile and automatically loads the appropriate configuration. You can activate profiles through properties, command line arguments, or environment variables. How do you handle exceptions in Spring Boot REST APIs? Spring Boot provides several mechanisms for handling exceptions in REST APIs. The recommended approach is using the controller advice class combined with an exception handler annotation. This is going to create a global exception handler that applies to all controllers in our application. This centralized approach allows us to define consistent error responses across our application and avoid the repetitive exception handling code in each controller method. So if we look at this, we can see we got a global exception handler class that is going to handle the resource not found exception. You can have multiple ones. For example, you got a generic one that is going to return a response entity with some kind of message. This is very useful for making production ready applications, as you want to return consistent messages to your clients so that they can read those responses and they know what to expect. What is Spring Data JPA and how does it work with Spring Boot? Spring Data JPA is part of the Spring Data family that simplifies database access by reducing boilerplate code. It provides repository interfaces that automatically implement common CRUD operations without you having to write the implementation. When you extend interfaces like JPA repository or CRUD repository, Spring Data JPA automatically creates the implementation at runtime. So Spring Boot is smart enough now and you don't even need to add the repository tag on these repository interfaces. We can also define custom query methods using method naming conventions, or we can write custom queries using JPQL with this query annotation. How do you implement security in Spring Boot applications? Spring Security integrates seamlessly with Spring Boot through the Spring Boot Starter Security dependency. So in your pom.xml, you need to have this dependency. Once added, it automatically secures all endpoints with basic authentication. You customize security by creating a configuration class that extends security filter chain. You can configure authentication providers, authorization rules, password encoding, and integrate with JWT tokens or OAuth 2. Spring Security provides protection against common vulnerabilities like CSRF, session fixation, and click checking. What is the difference between request mapping and specialized annotations? Request mapping is the generic annotation for mapping HTTP requests to handler methods, while specialized annotations like get mapping, post mapping, put mapping, and delete mapping are shortcuts that make your code more readable and explicit about the HTTP method. These specialized annotations were introduced to improve code clarity and reduce verbosity. You can see the difference between this get mapping request and this other get mapping. This one is way more readable and way shorter. Using these annotations make our API more self-documenting and follows RESTful conventions more naturally. How does transaction management work in Spring Boot? Spring Boot provides declarative transaction management through transactional annotation. When you annotate a method with transactional, Spring creates a proxy that begins a transaction before the method executes and commits it after successful completion, or rolls back if an exception occurs whilst running this method. Transaction management is automatically configured when you include Spring Boot Starter Data JPA. So when you have this dependency in your pom.xml, transaction management will be automatically configured. You can customize transaction behavior with attributes like propagation, isolation level, timeout, and rollback rules. And there is a simple example over here. What is the difference between RestController and controller? So the controller is used for traditional Spring MVC controllers that return views, while RestController is a specialized version designed for RESTful web services that return data directly in the response body. RestController combines both controller and response body, so these are two tags in one, which means every method automatically serializes return objects to JSON or XML without needing the response body annotation on each method. This makes REST API development more concise. How do you implement validation in Spring Boot? Spring Boot integrates bean validation through the Spring Boot starter validation dependency. You use annotations like not null, not empty, not blank, email size, and etc. There are many more you can search online, but these are some of them. And we use these validation annotations on our model classes. We then trigger validation with @valid or validated on controller method parameters. So we can see an example here. We got a create user request with some validation tags, for example not blank, this has to be an email, and then in our REST controller we activate that validation through this valid tag. When validation fails, Spring automatically throws a method argument not valid exception that we can handle to return appropriate error messages to the client, and we can do that through a controller advice where we got exception handler for that specific exception. What is command line runner and application runner? The command line runner and the application runners are two interfaces that allow us to execute code after the Spring Boot application has started. They are useful for initialization tasks like loading data, checking system requirements, or printing startup information. The main difference is that command line runner receives raw string arguments from the command line, while application runner receives a structured application arguments object that provides easier access to option arguments. And you can see an example here on screen. How do you implement caching in Spring Boot? Spring Boot provides abstraction for caching through the enable caching annotation and cache-related annotations like cacheable, cache put, cache evict. You can use various cache providers like EHCache, Redis, Caffeine Cache, or the simple in-memory cache already built in Spring Boot. We can see an example here. So we have a bean, which is the cache manager. So we enable caching on this configuration class, and then this is how we can use cache. So we got a cacheable with a value and the key, which in this case is going to be the ID in this method. Caching overall improves performance by storing frequently accessed data in memory, reducing database queries or expensive computations. Spring manages the cache lifecycle transparently through AOP proxies. I have a specific video on how AOP works, so you can check that out as well. How do you implement caching in Spring Boot? Spring Boot provides abstraction for caching through the enable caching annotation and cache-related annotations like cacheable, cache put, cache evict. You can use various cache providers like EHCache, Redis, Caffeine Cache, or the simple in-memory cache already built in Spring Boot. We can see an example here. So we have a bean, which is the cache manager. So we enable caching on this configuration class, and then this is how we can use cache. So we got a cacheable with a value and the key, which in this case is going to be the ID in this method. Caching overall improves performance by storing frequently accessed data in memory, reducing database queries or expensive computations. Spring manages the cache lifecycle transparently through AOP proxies. I have a specific video on how AOP works, so you can check that out as well. What is Spring Boot DevTools and what features does it provide? Spring Boot Tools is a set of tools that are required at development time that enhance the development experience. It provides automatic application restart when code changes, live reloading for static resources, and additional debugging capabilities. When you modify a Java class, DevTools automatically restarts the application much faster than a full restart because it uses two class loaders. The base class loader handles third-party jars that don't change, while a restart class loader handles handles your application classes that you might have changed. You can see some of the application.properties that you can define to set the behavior of the Spring Boot DevTools. How do you implement custom validators in Spring Boot? While Spring Boot provides many built-in validation annotations such as @valid, @email, size, and etc., you can create custom validators for specific business rules. You can create a custom annotation and an implementation of the constraint validator interface that contains your validation logic. This approach keeps your validation logic reusable and declarative, allowing you to apply the same validation rules across different classes or fields by simply adding the annotation. We can see a quick example here of a custom annotation which is called unique email. We then have a component which is the unique email validator that actually does the logic of the email validation, and here is an example of how to use that. You can then simply just add this new tag that will be provided by Spring Boot. How do you implement scheduled tasks in Spring Boot? Spring Boot provides scheduling capabilities through the scheduled annotation. You enable scheduling by adding enable scheduling to a configuration class, then annotate methods with schedule to specify when they should run. Here you can see examples of how to run scheduled jobs. You can use cron expressions for complex scheduling, fixed rate for regular intervals regardless of previous execution completion, or fixed delay for intervals starting after the previous execution finishes. How do you implement asynchronous processing in Spring Boot? Spring Boot supports asynchronous method execution through the async annotation. You enable async processing with enable async annotation and annotate methods with async to make them run in a separate thread. This is useful for time-consuming operations that don't need to block the main execution flow. Async methods can return void, future, completable future, or listenable future, allowing callers to handle results asynchronously or wait for completion when needed. So you can see an example. We've got enable async on this configuration class where you define the size of our thread pool executor. We then have two methods annotated with async. One returns void and one returns a completable future. How do you implement logging in Spring Boot? Spring Boot uses SLF4J, which stands for Simple Logging Facade for Java, with Logback as the default logging implementation. You can configure logging levels, patterns, and output destinations through properties or a logback configuration file. So you can see here an example of application.properties configuration for logging. Proper logging is essential for debugging. So for example, when you have a service class, adding logging is quite useful in case you have any kind of issues. So proper logging is essential for debugging, monitoring, and understanding application behavior in production. Spring Boot makes it easy to configure different log levels for different packages and control log output format. You have to be careful with logging in production and make sure to not log sensitive data anywhere that is easily accessible. Here were some of the most asked Spring Boot questions during software engineering interviews. Let me know in the comments if you want me to do a part 2. And if you're wondering how I keep my coding skills sharp, then check out Brilliant. Start the new year by becoming a better problem solver with the help of Brilliant. Brilliant helps you excel in math and computer science with visual, interactive problem solving and personalized practice. Brilliant turns anyone into a math or computer science person, and you can rest assured that every course and problem is crafted by an expert. What I love about this product is the vast amount of lessons available to train your mind and stay sharp. Brilliant personalizes learning for you. It starts you at the right level based on your background and helps you advance at your ideal pace. To learn for free on Brilliant for a full 30 days, go to brilliant.org/LeetJourney, scan the QR code on screen or click on the link in the description. Brilliant's also given our viewers 20% off an annual premium subscription, which gives you unlimited daily access to everything on Brilliant. Thanks Brilliant for sponsoring this video.